All right, what you're looking at here is the device that's being video cammed by a Logitech Brio. Okay, and these two dots, this one is on the support structure, which holds the device, and this one is on the flange of the device itself.
Okay.
Okay, so these dots record the motions of these two parts. Conservation of momentum requires that if this one goes this way, this one has to go that way, and so on. Inverse proportion to the masses of the device and the parts, the support structure and balance beam and all that. Mass of the device is about 150 grams. The effective mass of the support structure is about 885 grams. Okay, so this doesn't move much when this moves a lot. So what you're going to see is this thing move. Okay, you're not going to get a full video of the entire device, but you can't do that even with your fancy cam unless I go and move stuff around. Okay, over here we have, actually this is probably the most important trace. That's a picoscope strip chart recording.
Okay.
And what it's recording is the position of the device, or actually the support structure, as a red trace that's buried in the blue. The blue trace is the applied voltage across the device, which gets filtered after the run is done. This one is the strain gauge, which is mounted in the stack of the device about here, which tells you what mechanical activity is going on. And that gets post-run filtered too. Okay, so the first run we're going to do is on device HR. And we're going to be doing it at a sweep rate of the frequency that we sweep of 2 kilohertz per second, no, 1 kilohertz per second. We're going to be sweeping from 45 kilohertz to 25 kilohertz in 20 seconds, and it will repeat. It does it once, and then it does it again.
Okay, so you're sweeping through those sweet
frequencies.
spots.
Starts at 45 kilohertz. The resonance is at about 35 kilohertz. Sweeps onto the resonance, you get an effect, and then it sweeps off and settles, and then it goes back and does it again. Okay, this is part of a set that I'm going to do today, because the next run after this is going to be at 500 hertz per second instead of a kilohertz per second, because I found some interesting stuff in some data I got the other day that suggests a closer look. Okay, so I pressed record here, counts down, 3, 2, 1, and then I turn the power on.
So we're starting the test.
Yes, this is it starting. That's a waveform. Blue is voltage, red is current.
Okay, so blue is voltage, red is current.
Green is the strain gauge.
Oh, okay. And the strain gauge, if I remember right, is a couple of extra piezo sensors, right?
Yes.
Except that instead of action, they're
0.3 millimeter thick
measuring.
piezo.
Yeah.
Here's the second straight pass. And I go up here and right.
So this is how fast it's moving in real time then?
Yes, it's real-time moving. Okay, now what I need is this and this. Okay. Save as. And I want to get the right file folder. Select folder. Okay. Basically, I put everything in the file name so that so I can forget actually. I know what it is. Okay. Folder.
So you're saving the entire video file plus the data.
Yes.
Yeah, that's nice. Then you can review it all at once.
You can take a look at pretty much anything you want. You've got the video file so you can see what's going on with the fast Fourier transform here. And you see it goes way up on those two when it does its thing, and then it drops back off. This is a waveform, so you can just look at it and see what sort of harmonic content the phases are.
I noticed rotation on that.
Yeah, that's because it's loose.
Okay, so that's,
It's not a big deal.
yeah.
Those sleeves I put on just as extra precaution for short circuiting and so on.
I wasn't sure if it was supposed to rotate or it sounds like just when it moves. Yeah.
No, it's doing pretty much what it's supposed to do. Okay, now let's stop that. And let's see. This is the one that I want. Quick access. Okay, now I'm going to save this. And it's popping up there. Now I take this. Move that over there. And now we have both the picoscope file with the.
And are you running more right away? Mm-hmm. Are you running another one?
Yeah.
Okay, you know what? Let me take this, if it's okay, let me take this camera and I'll put it right in front of the, I won't disrupt your camera, but.
Please don't.
Okay, there we go.
Okay. All set?
Yeah, I think I'm.
Are you going to take a movie of that over? No, you've got the thing here. You can't take a movie of it.
Well, I can use the
Oh, you're
files.
taking a movie of us. That's okay.
Yeah.
Yes. All right. I got it. Okay. Are you ready?
Yes, sir.
We're going to do the same thing at half the speed. Okay, here we go. 3, 2,
Well, let me thank you again, and please don't let me disrupt or cause trouble for you.
not a problem.
One of the things that I really like about this setup is that you have everything run onto the computer and it's visible in the same place. And it's worth highlighting the fact that you're able to save the entire run as a video file.
Oh, yes.
Yeah, that's...
Yes. No, that's, you live and learn.
Well, and I was looking at the equipment, the oscopes and signal measurement tools, and I thought, I was just thinking back to the old days, right, where you'd have to check one thing and check another thing, and now you've got it all there, and you've got documented evidence.
Yeah. Yes. It's taken a while, but we're getting there. Okay, 26. Playing it back after the run puts it up in the computer so that it's on the...
Now, does this behave differently in a vacuum than it does in air, or is it just to prevent arcing?
No. In air, it acts as a little air pump. So you get a spurious signal whether you want it or not. You know, only if you're foolish do you ignore it. We ignored it for several years. And then it, I guess it was George who said you really need to see if it's pumping air. Nimbo Baldrini also did. And so what I did was I went back and I stuck a few baffles in critical places that would tell you if it was pumping air, and sure enough, that's what it was doing.
Let me adjust your camera a little bit back to where...
Okay.
Okay, there we go. Because I think when I...
Okay.
So it's very meticulous and painstaking, but I love that. It's, you know, Drew Rigma had said this when I visited him in Florida. He said, change one thing, do a test. Change one thing, do another test.
Yeah. Yeah, the temptation is to change more than one thing at the same time. It's always present. Because there are things that you know need to be done. But if you need to know which it was that fixed the problem, you do them one at a time. Okay, now we're going to go back and do the other way. Let's see what we've got here.
Did I move the camera too far the other way? I did. I tried to. Yeah, I did.
Yeah.
If I can get a view in real time. Hold on. There we go.
There it is. That's fine.
There we go. Okay. Hopefully that works. Sorry about that. I wanted to have it centered for you.
Yeah, that's doing more or less what I expected. So a little over to it. Let's do it a little bit. Okay. And now I have to get back to this. Okay, and now we go. Okay. All right. Okay to go. Here we go.
Okay. Oh, when you're running it. Okay. Oh, you're saving another one. Okay.
Yes. 73. I'm not paying attention as much as I should. It's real easy to be distracted and forget what you were doing. But we're going to get fast, slow, and then I'm going to reduce the driving voltage to see if I can clear up the clutter. That's a fast one. Okay. Oh no. I lost the picoscope file on that one. Let's see if it's in waveforms. Let's see if I can find waveforms. Let's see. Some of these waveforms.
Hey, Curtis.
Come on in, Curtis.
Morning.
You caught me in a blunder.
Roar, are we recording? I've already got it set up.
Great. I can do that wrong.
Okay. Well, hey, here, do you want to sit down?
Yeah, good to see you.
Yeah.
Okay. Now, minimize that. And I want to minimize this. And go in here. Sorry guys, my fault. I screwed it up. Okay,
I'm gonna grab the chair. I'll do it.
grab a chair.
And let me see. I wonder if I can. There, I'll get this out of the walkway. So now, yeah, it went well. Well, it's good if I don't meet you in person. Now that I know that somebody has a weakness for Oreos.
But Java chip and toffee are my favorites.
Java chip and toffee. Okay, so I'll make a note.
Yes. Okay.
Well,
We're
because
gonna
now it's in my head, so I'm gonna go.
we're gonna do that one over again. Okay, all set to go.
You been doing some runs, Jim?
Yeah, I've been doing some runs.
Yeah.
Can I see the new device?
Well, and it's wonderful to get
No,
the
it's at
video.
home. I have to solder the strain gauge back on yet.
Okay.
It's not getting. Jim says that David Chester is coming out tomorrow afternoon,
Okay.
so we want to keep this one on the balance until tomorrow afternoon. Yeah. And then tomorrow afternoon, while David Chester is here, if you want, we can change it.
Swap it out. Yeah.
Swap it out and put the gears on and see what it does.
Sounds good.
Yeah, my only worry is the background noise. I would love to do some at some point later. I'd love to do some interview footage without the
Someplace else.
someplace else. Yeah.
Yeah, no, turning off the pump is not a good idea.
We can do it for a short time.
You can see now.
It's okay. We think of some. It doesn't have to be.
It's a 2.0 times 10 to the minus 4th. That's from yesterday when it was 2.3 times 10 to the minus 4th. And the reason why it's taking so long is because we had a power outage about a week and a half ago, and all the pumps shut down. Power came back on. The turbo pump went into safe mode, which Curtis programmed, and the 1402 turned on. But at those days, and indeed even now, RC, we did not put wing nuts on the studs that hold the bank plate on, because you don't need them for normal operation. But the problem with that is if the 1402 goes off and something leaks in the system even slightly, that plastic plate falls out. And when the power comes back on, the 1402 starts pumping atmosphere through the chamber. And it keeps doing it as long as you don't fix it. And as far as we can tell, it did it for 10 hours, 12 hours.
Okay, so 10 hours of slow.
And it's taking forever to pump the damn crud that got picked up in that out.
Well, so this is one of the things, and we can go more into this later, but we should work on coming up with a parts and materials list of things.
Yeah,
that you guys
a better
need.
1402.
Yeah, I mean, because Jim mentioned a better roughing pump, right?
Yeah, that's the
Like, I know Mark Sokol has him, and then Drew. I mean, between the two of them, they have a lot of equipment.
Yeah.
So
Yeah, there's some limitations because you see that vacuum chamber there at the back. That turbo pump conventionally should be right on the back of that chamber, like directly on it. And so we would have to, in order to do that, we would have to machine a new backplate. And so that is,
They don't sell 1 1/8 inch bulletproof plastic plates on. I bought them when they were being remaindered out and got the last few of them. They haven't had them in years.
well, we could do it out of aluminum, but that's,
No,
I mean, that would be a bigger problem.
aesthetically unappealing.
I'll make it shiny.
Yeah. No, making it shiny is not a substitute.
A mirror finish will look like it's, Anyway, so there are some limitations like that, but definitely the roughing pump is a problem. And we could probably get the turbo pump instead of having that right angle, have it directly on there, but that would involve designing some supports. So
well, one of the things that Jim mentioned last night was, and again, it's something I know. It's like you know it, but you don't know it, right? And like he mentioned newtons of force from watts of input, and so part of it is like, how can we find the materials that you guys need to help you get to that place where you can really demonstrate that for people?
yeah. So that side of it has more to do with what we're using to drive the signal and the feedbacks.
I told him about David's amplifier that's been just about done for the last 3 years.
Yes.
Yeah, the sweet spot, I think.
Yeah. Yeah.
So so that is, I mean, controls and feedback, that is kind of one of my specialties. So I have some things in mind for what to do.
Curtis is going to beat David to it.
The trick, well, we'll see, but the trick is there are some limitations with the hardware we have.
Okay, I need to get another run like the last run. Kilohertz per second, here we go.
Yeah, but one of the things that's exciting to me is collaboration between these different labs,
Yeah.
right? And I mean, when I was on the East Coast, we drove up to Massachusetts, and he was helping them fix a roughing pump so they could do vacuum chamber work. And and they've helped him with material stuff to test. And so, it just because it's a pretty small community.
Yeah.
So ultimately, we've only got each other.
Yeah, that's right.